This video will be about the research into AFM cell mechanics. AFM standing for atomic force microscopy, a commonly used method for high-resolution mechanical measurements. The slides that will be shown are provided by the Bruker Company from their virtual event, Novel Concepts in Mechanobiology, from individual cells to cancer tissues, specifically those of the first presenter of the event, Dr. Maria Guevara. Dr. Maria Guevara is a PhD in cell biophysics at the University of Barcelona. She researches mechanobiology and the mechanical behavior of cells. Projects led by Dr. Guevara and her team include research into cancer-associated fibroblasts, using the cytoskeleton as a biomarker for health and disease, AFM cell mechanics, and more. Dr. Guevara, in her work in AFM, studies primarily the mechanical properties of the cytoskeleton, which is the structure shown on the bottom left. The cytoskeleton is important to our research because it provides shape and mechanical stability to the cell. It is involved in many cell functions, rate, and behaviors, such as migration, division, and differentiation. In the field of biomedicine, cytoskeletons are involved in physio and pathological states that include development, body movement, healing of wounds, cancer, and inflammation. Thus, the cytoskeleton can be used as a biomarker for disease diagnostics and also drug discovery. There are three important cornerstones in cell mechanics. The first is a good EFM setup. So it is more important to use a suitable contact mechanics model relevant to the nature of the sample, or the second cornerstone. Finally, the third cornerstone, which is the importance of having a good approach towards data analysis. A good AFM setup includes a force feedback mode, which collects data more quickly and also blurs the boundary between imaging and mechanics, providing the possibility of obtaining maps of multiplex data, which include not only topography data, but also elasticity and adhesion data. Data analysis is used in AFM for the following reasons. One is to obtain better, more accurate data. Two is to have more mechanical parameters for better understanding of the biological structures. And three is to tap into fields such as machine learning. The AFM measures voltage and not force as commonly believed. The simplicity of measuring voltage with an AFM can be a burden in addition to being a benefit, as constant and precise calibration is needed. To measure the mechanics, the force applied needs to be linked to the sample deformation. It should be noted that AFM does not directly measure the force nor the indentation of the sample. It should not be confused with the deformation of the cantilever. In the usage of data analysis, one of the mechanical parameters obtained is a simplification of viscoelasticity measurements through the differences in approach and withdrawal curves. More data can be obtained with better analyzing techniques through depth sensing, viscosity with the familiar protocol of FB curves, and the topography analysis of the cell. Mechanical screening and profiling can lead to more data obtained if the parameter for a given study is narrowed down to the ones with the most biological significance. Mechanical profiling of a hypothesis-free approach. Identifying measurements better suited for classification and diagnostics.